Hello and welcome to m252 Calculus 2 here at Cañada College. My name is Lapuz. In this video we will be looking at checkpoint 3.18 from section 3.4 where they're covering partial fractions. In this problem they want us to evaluate the integral of x plus 1 divided by x plus 3 times x minus 2. So clearly this is a partial fraction decomposition. And the idea is to take a big fraction like this and rewrite it algebraically into two smaller fractions. So there's really not much calculus going on in the partial fraction decomposition itself. It's more of an algebra topic. And the idea behind that is to write your fraction, your big fraction, x plus 1 divided by x plus 3 times x minus 2, and write this as two smaller fractions where the denominator is going to be of this factored form. So it's x plus 3 for the first fraction and x minus 2 the denominator for the second fraction. Now the term that goes on top, or the factor that goes on top, would just be constants. So it's going to be 1 degree down from the term in the bottom. So if your term is linear, then in the bottom, then your numerator will have a constant term. And these are going to be two different constants, so we'll label them just A and B. Now, in algebra, when we first learned about fractions, we're used to going from two separate fractions with common or not common denominators, and then we have to find common denominators to combine them to get one big fraction. Our task here, so this is our algebra, our task here is to rewrite a complicated fraction into two smaller fractions. So this is our decomposition, and it's called decomposition because we're decomposing it to smaller fractions. All right. So how should we do this? One way to do this is to multiply the whole thing, both the left and the right side, by the common denominators. So that's x plus 3 and x minus 2. And in doing so, the whole denominator will disappear on the left-hand side, leaving us with just the numerator, x plus 1. And then for the right-hand side, when we distribute this into the first term, the x minus 3's cancel. I'll just have an a times x minus 2, or x plus 3's would cancel, and I will just have an a times x minus 2. And then when I distribute to the second term, I will have the x minus 2's will cancel, so I will just have b times x plus 3. All right. There are several ways to go from here. One way I like to do it is to distribute everything and combine like terms. So I will say x plus 1 on the left-hand side does not change. I will distribute ax minus 2a for the first term here, and then the second term will get distributed bx plus 3b, and so now I have these terms, and I will combine the like terms. So in combining the like terms, I can also factor out an x. So I'll have an a plus b combined, multiply that by x. And then I have the constant terms left over. That's going to be a minus 2a plus 3b. And then the fact that these are all equal to x plus 1 tells us that if we match the coefficients, we have a coefficient for the x that should equal to the coefficient for the x on the left-hand side and the right-hand side, and the constant term should equal to the constant terms there. All right. Now we have two equations. The first one is going to be a plus b is equal to 1. And then our second equation is going to be minus 2a plus 3b is equal to, it's also equal to 1 because that's our constant term on the other side. Okay, Now, at this point, we have two equations, two unknowns. We should know how to deal with this. For me, I think I will take the first term, or the first equation, multiply everything by 2. So that's 2a plus 2b is equal to 2. I'll keep the second equation the same, minus 2a plus 3b is equal to 1. And I will go ahead and combine or add these two things so that the a's will go away. I'll have 5b is equal to 3, so b will equal to 3/5. I'll put a box around that, and then I will take this b and put it into either or any of these equations that I have, and I'll just put it into the first one because that one's the simplest. Whoops, sorry. I will have a unknown right now. B is equal to 3/5 is equal to 1. And so a will be 1 minus 3/5. 1 minus 3/5. And so combined denominator, 5 over 5 minus 3 over 5. That's going to be 2 over 5. So that is my a. All right, so we found our a and our b. A is equal to 2/5 and b is equal to 3/5. And now I can rewrite my complicated looking integral by writing it as a is equal to 2/5 divided by x plus 3, and then b is equal to 3/5 divided by x minus 2, and that is my new integral, which I can break apart, separate, and integrate term by term. So there's two terms here. So this has a constant of 2/5. The integral of dx over x plus 3 will be a simple u substitution. U is equal to the denominator, and then that's going to give me my ln of x plus 3 term. And then I'll have the same deal over here. I'll have 3/5 ln of x plus x minus 2, and then throw the plus c in there. So that is my final answer, and that's the partial fraction decomposition. I wanted to show you just quickly another method where I could take a look at this expression up to here, and we're solving for a and b in this case. So I just want to bring that back down here and show you another method of solving for a and b. And this works for partial fraction decomposition where the denominators are all unique or distinct, but there are some times where our denominators will have to be squared or cubed or anything like that, and in this case it won't work so well. And so this is just another method. Sometimes it's called a substitution method or Heaviside method, named after somebody named Heaviside. But what you could do is you can let x equal to something that would make one of these variables disappear. For example, if we make a, or if we make the b disappear, let's let x equal to -3, and then putting that into the equation, I'll have -3 plus 1 is equal to a times -3 minus 2 plus b and -3 plus 3. And so this will be 0. And now we've gotten rid of b, essentially. Here we have a -2 on the left-hand side. This is a times, this is a -5 if we combine them. And then so this will give us an a value of, let's divide by -5, so that's going to be +2 over 5. And notice that that's what we got before. And we can also let x equal a +2, and in that case 2 plus 1 is equal to a, and then 2 minus 2. That would be 0, which means a will disappear. And then we have b, and then 2 plus 3. So we have 3 is equal to 0 plus 5b, and so b is equal to 3/5. Okay, and that's what we got before. So this is just another method to find those arbitrary constants. They're not arbitrary, to find those constants that we need to fill in for the partial fraction decomposition. And again, this works well if you have distinct denominators, but when you start taking your denominator and squaring it, or you have an irreducible quadratic, then this isn't going to work so well. But this method over here, where we match up the common terms, the like terms, that would always work. All right, I hope that helps. Good luck.